All right.
Welcome to Data Council Thursdays. I'm Pete Soderling. I'm the founder of Data Council and the Data Community Fund. And I'm super excited to welcome you to DC Thursdays, where we sit down with leaders of top open source data projects. So if you've ever wondered why the data engineering world doesn't resemble the rest of software engineering in terms of automated testing, tools like Great Expectations are helping to bring us out of the dark ages. Great Expectations helps teams eliminate pipeline debt through data testing, documentation, and profiling. Indeed, pipeline debt is a term coined by Abe Gong in a Medium post back in February 2018 that struck a chord and channeled a significant amount of angst out of the data community as data engineers finally felt they had found someone who understood the pain they had been feeling and was advocating not just a clear conceptual framework, but even more importantly, an actual tool to solve this problem. So I couldn't be more excited to welcome the man himself, Abe Gong, to the show. Abe's a co-author of the Great Expectations data testing framework and is also the co-founder of Superconductive, the company he launched to support the development of Great Expectations and also to provide commercial options for its advancement. Abe was previously the chief data scientist at Aspire Health and also the first data scientist at Jawbone. So Abe, welcome to the show.
Thanks, Pete. It's awesome to be here. This is the first time, right? This is the first show of this post-COVID new whatever we're going into in terms of conference formats.
This is the first time, and it's the first time most people have seen us with our new haircuts, post-quarantine haircuts. So we were lucky enough to get appointments prior to chatting today. But yeah, we're kicking it off. This is ground zero.
Awesome. It's good to be here.
Yeah, thanks, Abe. So let's get right into it. Data testing, data quality, in your view, why are these things important?
We've got a little spiel that we do now, which is, put it this way, I did this for the first time at Data Council back in November, but I think this resonates. It's worth describing it this way to people. So if you're a software engineer and you build a really cool API and you say, hey, I've got this really cool API and I'm going to ship it to production and I want you as other people to start relying on it. But by the way, it's not documented and there are no tests for it. Oh, and it might change and I wouldn't even know if it changed. So, good luck with that. I think in the rest of the engineering world, software engineering world, you would look at that and say, that is totally crazy. That that's not really engineering yet. You've got a thing that works right now, but you can't guarantee it's going to work in the future. That it's just hard to rely on. We've got a lot of people that are relying on data systems, and weirdly, if you look at the average table in the average data warehouse, most of them aren't tested, most of them aren't documented, and a lot of them change without warning. So we see data quality as, it's these like two little words that you can put on all kinds of pain and frustration that come out of relying on things that haven't been fully engineered to be reliable.
And did you know that your Medium post would strike such a chord with the community when you were preparing it back a couple of years ago?
I mean, you never know with those things. I had a hunch just because I had experienced that pain in every job that I worked at, and I know a lot of very good data engineers, and we talked about similar things. So I knew that we were onto a real pattern. What I don't think I could have predicted is how many other people see the world the same way and really liked that framing of it. And it's been really cool to see. I mean, I'm certainly not the only person advancing thoughts in this area, but to see that specific set of thoughts gain momentum and traction and snowball over the last couple of years. And by the way, you're saying that this is my post. I just want to make sure to give total credit to James Campbell, who was my co-author on the library from very early on, and more recently other people like Eugene Mandel, Alex Shertinsky. I'm not going to be able to name everybody on the Superconductive team, but it's an awesome team and it's definitely a group effort. And even beyond that, we're not quite at 100 contributors on the project, but we'll probably get there in the next few months. So it's increased. It's kind of fun being the figurehead for this thing sometimes, but I'm not doing most of the thinking of the work. That's what I want to say.
Well, that's great. The team is important. And how did you personally, though, get sort of dragged into this space? I find that many times the best origin stories from some of the best tools or companies from the founders themselves, there's almost a force of nature involved in sort of what dragged them into this opportunity, and what was happening for you that sort of made you realize that you were in the right place at the right time and had a perspective on this stuff that could be valuable.
Mm-hmm. I think there've been a couple moments on that. The most recent one, like the most recent big one, was last year. I was running this company, Superconductive. It was actually originally founded to be a data consulting company for healthcare. We were Superconductive Health. And last year, we started to get a bunch of inbound requests from people I'd never met who had nothing to do with healthcare. And they would say, like, hey, we know you've got something to do with this library. We've got real data quality issues. We like the way you're thinking about it. And even though we're not healthcare, like, we've got dollars. Can you help us solve this problem? And as an entrepreneur, after you get a certain number of those calls, you say, okay, something's really happening here. This seems to be a broad horizontal thing. So yeah, that was a real pull moment.
And how would you say that teams are solving their data quality issues now? Like, what does that look like, or at least sort of pre-Great Expectations? What sorts of tools or scripts or checks, or like, how did folks cobble together stuff before this sort of data ops era that we're stepping into?
I think cobble together is the right language for it. You see a lot of people home growing systems. Big companies will sometimes put together something that looks kind of like Great Expectations and make that a framework. Sentinel out of LinkedIn, for example, was published some of their stuff recently. There are a lot of kind of philosophical things that I agree with in that project. Smaller companies, it's usually just people and maybe some scripts. I've met a lot of companies where somebody every night at 10 o'clock has to sign in, run some scripts against the data warehouse, and then copy paste the results into Slack. And if something's wrong, okay, well then somebody gets called at 10 o'clock at night. So it's messy.
And so, like, moving into some topics specific to Great Expectations itself, what were some of the design principles that you used when you started to imagine what a world could look like with better quality data testing tools? Like, what were your guiding principles?
We made one decision very early on that I think it was intuitive, also strategic at the time. We felt like you could unlock more if you did it this way. And that was the notion that so this notion of an expectation, an assertion about data. Well, first, it should be an assertion about the data, not about the code, because in data systems, data is the thing that is changing more frequently. And if you want to really guard yourself against the vagaries of unpredictable change, you've got to test that. That's where most of the complexity lives. So that was one thing that I think was genuinely new at the time. The other decision that we made was to do a declarative language and to say, hey, yes, of course, you can always write your own little custom SQL snippet or a few lines of pandas code or something like that. But in order for these assertions to be as valuable as possible, they should be semantically meaningful, which means that having them as clear declarative things, expect column values to be in set, or expect column mean to be between. Being able to assert it that way would create a lot more value in the long term. And I think that's been borne out. There's actually more to come there, but we're already seeing that borne out in a very clear way.
So the core abstraction of the system is this notion of an expectation surrounding your data. You have stock expectations that sort of come pre-baked, in addition to presumably user-defined versions or flavors of this?
That's right. So out of the box, Great Expectations ships with about 50 standard expectations. They're domain agnostic, so null values, date times, sets, ranges, means, medians, maxes, the kind of standard things that apply everywhere. And then we've also got the capability to extend the library with your own custom expectations.
Got it. And so how would you describe the main use cases of the tool?
I think the main use, it's a big question. So sometimes we get asked like, hey, is this an ETL assistant? Is this good for machine learning? Do I use it in my data warehouse? And the answer is yes, like all of those use cases. One of the things that we've worked really hard to do in Great Expectations is make it as infrastructure agnostic as possible. So you can execute the same expectations in Pandas, in Spark, and against almost anything that supports SQL Alchemy. There are a lot of libraries there. We're still building out into some of those edge cases, some of the lesser used databases. But what that means is anybody who is dealing with data flowing through a system that touches multiple pieces of infrastructure, you can use consistent terminology, again, this declarative thing, and consistent expectations, and make sure that it holds together at each stage, even if there are a lot of jumps through your data pipeline.
And this is specifically designed to be implemented on sort of on batch, in batch mode, correct?
Yes, although I don't want to take streaming off the table forever. What I'll say is there are a lot of expectations that make the most sense to evaluate in chunks of data, in batches of data. So for example, if you want to check the mean, or if you want to verify that no more than 95%, at least 95% of values are not null, those two things only make sense in the presence of a batch. That said, we think down the road, there's probably room to extend the terminology upstream into the streaming systems of the world.
Got it. Interesting. I want to mention to the audience as well that we'll save some time for questions at the end. So you can feel free to contribute your questions in the YouTube chat, and we'll do our best to get them answered once Abe and I finish our conversation. So please jump in the YouTube chat and let us know any questions that you have for Abe as well. So back to GE. Abe, when does an engineer typically implement?
Pete, by the way, I love that you call I love that you call it GE. That so much marks you as an insider on this.
not the monolith or the huge multinational company with that brand. You're not concerned about infringement or sort of abbreviation colloquialisms.
I have to talk to lawyers, blah, blah, blah. we sometimes joke about this. We say, like, if this gets big, we're competing with like the two worst group, or I don't know, worst, but two tough groups for SEO. One is GE, the company, and the other is Charles Dickens. And those are both hard SEO fights.
Well, neither are sponsors of this show, so I think we're safe for now.
Is that how it works? Okay.
So when an engineer typically implements a tool, what does that look like?
So what we usually see is people will come in and start off, and when I say see, I'm generalizing here from conversations with lots and lots of users in our Slack channel. So we've got almost 1,000 people in the Great Expectations Slack channel, just wonderful and amazing. It didn't exist a year ago, and now there's all this momentum. What we typically see is people will come in and do one of two things to get started. Some people say, hey, I just want to kick the tires. I'm not sure that I need this. I'm not quite sure how it works. So I just want to play with this notion of an expectation in a notebook. So let me load that up in a data frame and then experiment with it and poke at it for a while. We've got some good early tutorials on that. We're actually refreshing those right now to make them kind of fully up to date with all the latest changes. So that's one workflow. The other workflow that usually comes after that is you have a team that has kind of read enough to be confident and like feels enough pain around the need for data quality monitoring, data documentation. They say, yeah, we want something like this, and we're ready to get started. In that case, if you just pip install Great Expectations and then do Great Expectations in it, it'll walk you through the process of a deeper setup. So that's everything from configuring what we call the data context, which is sort of the manager for all the relevant pieces, to configuring data sources, to building your first set of expectations, to setting up what we call a checkpoint, which is a way to schedule and monitor data quality checking. Oh, and data documentation as well. Actually, Pete, we haven't said this here. It's probably worth mentioning. One of the cool things that comes out of this declarative syntax for expectations is you can compile your tests into your documentation. And what we found is, I'd say the promise of this is still early. There's still quite a bit more to do to like fully develop this part of the ecosystem. but the notion that your docs can be your tests and your tests can be your docs, and that they'll always stay in sync, and they'll always, as long as you're running your tests, they'll always reflect the current underlying reality of the data. That's a nifty promise. It's not a thing that has existed before. Most data teams that I know have the chronically stale wiki that tries to document the data, but like it's almost like you have to do your work all over again to make sure that the wiki's up to date. And so it never is, of course. I wouldn't say we have completely fulfilled on the promise of taking all the friction out of that workflow, but I think we're the best game in town for it. And it's exciting to see people pushing on that, contributing to making it happen.
Yeah, that's super neat, because to me that represents a touchstone for a broader collaboration opportunity with teams as well, because no longer is the quality and the origin and sort of the responsibility of the data flowing through the system, only one of the data engineer, but the data engineer has the opportunity through GE to basically establish this vocabulary. Do you call it a data dictionary? I mean, we're sort of blending some terms from older eras, but there's also the data catalog concept, which we'll actually be talking to Mark Grover from Lyft about in our next episode. But separately from that, do you see GE as potentially powering, first of all, collaboration across different types of roles in the data ecosystem or the business ecosystem, and also could it become potentially the foundation for data dictionary, data catalog, these other sorts of concepts that we also know the world needs?
Okay, two parts on that. So one, yes, absolutely, on speaking to what we think of as developer adjacent roles. So one of the things that we've been very conscious of with developing Great Expectations is we want it to be super, super developer friendly. So it works with notebooks, it plays with all the infrastructure that people have already. We've kind of bent over backwards to make it customizable and pluggable and extensible, so that as an engineer or a data scientist, somebody who writes code, you're always in total control of what it does. And of course, we can make a lot of things easier too. That said, part of our job as being really developer friendly is to help developers collaborate with all of the people who sit next to them. I think a thing that is different about the data world than most other types of software engineering is in software engineering, most of the kind of the inputs and the outputs and the moving parts, they're self-contained. Like if as an engineer, you really understand how your stuff works, then you understand most of what you need to know. In data, we've always got this notion of a data generating process, right? Something that happens in the real world that then flows into your system. And because so much of what is happening in the data system is being driven by that upstream DGP, there's always going to be a tighter collaboration between the data folks, or the engineering type data folks working within the software and data system, and then all of those adjacent roles who understand why, what's happening upstream, why does it do what it does, what should it do. And so the need for collaboration across those boundaries is, I think, relatively large in data relative to everywhere else. And so kind of empowering communication, fluid communication across roles and across different skill sets is a big part of what we want to be able to do.
Got it. So coming back to this docs feature, what's sort of the next steps on making that even more robust? Where are you now, and where are you headed with that in the near future?
So I actually think there's a hop in the middle, which is what we've called data profiling. We've tried to be very open about this, that data profiling is still sort of an experimental feature. We're now in a place where there's a Great Expectations scaffold command that's pretty good. There's still a lot that can be done, but it's a pretty good starting experience to get in and not have to write all of your tests for yourself, and to have power tools that allow you to do those workflows kind of many at a time. Again, there's still more to do there, but the way I see this flowing through is as we enable users to just fluidly create more expectations, to build out their test suites and build coverage, deeper, wider, thicker, faster. You move from a place where you have to kind of do it piecemeal to a place where you start to be able to actually bring large chunks of your data pipeline under test very quickly. And the output from that, yes, it's testing, but it also does start to look like a data catalog. And we're the way we're thinking of it is, if you already have a data catalog, we want to be able to flow into that and kind of pipe our output through so that it enriches the experience you've already got. If you don't have a data catalog at all, then Great Expectations docs can be kind of the version 0 of that. And then, like all good tools, you can build on top of it.
Mm-hmm. Got it. And this profiling part of the system, it sounds like this is very useful in helping folks get running on GE like quickly. So how long does it typically take for a team to see results? I know through Data Council, for instance, from last year, you had offered some custom consulting support help to the community in getting up and running on Great Expectations. And of course, that was particularly useful at the time because the tool was even newer and perhaps didn't have batteries included, as you like to say. What's the status now, and how long does it take teams to get quickly up and running on the tool?
So at the time we were saying schedule it, and I kind of hate this word, but we've never found anything better. We call it a deployathon. And we'll like our whole team will work with your whole team for a day and we'll get everything up and running. At this point, we're pretty reliably able to do what would be done in a deployathon in an hour, maybe 90 minutes, as long as everybody comes with credentials. And most of that is not the mechanics of going through and making the code work. Most of that is discussion about how do you want to deploy this? How do you want to configure in your environment? So it's mostly about engineer choice. And
right.
what I expect to happen over time is we'll have sort of standard playbooks that fall out of that, and we'll be able to kind of productize that even further. But even now, I'm pretty confident saying, like, if you're thinking about data quality and it's a choice between home growing something or just kind of cobbling it together versus taking an hour or two to get a first deployment up, I think that's a pretty easy comparison for most people to make.
And are you willing to guide this community through those steps inside your Slack channel, for instance, that you mentioned? Is that the appropriate place to for someone here who's interested in the tool to kick off that engagement?
Yeah, so if you're interested, definitely jump into our Slack channel. It's greatexpectations.io/Slack. I will say we're starting to be bandwidth constrained on that. And so, please speak up and we'll schedule time. But a few months ago, it would have been like, yeah, we'll do that. Whenever you show up, we're happy to help. We're still trying to be like super high touch, super helpful about getting people started. But we've got, and for the last several months, around 100, in many cases, more than 100 people showing up every month in our Slack channel. So, just that rate of new arrivals, it's a little bit hard for us to keep up with everybody who needs really high touch help.
Well, that's great that the community is growing so big and so quickly. And I'm sure, regardless of whether you're able to give custom high touch help to each individual, their common concerns, questions, issues, you're sort of able to funnel into other formats, documentation, training, talk materials, et cetera. So I'm sure that interaction from the community is helpful either way.
Yeah, I mean, one of the things that's been really cool to see is, and that wasn't really the case 6 months ago, is we've got a lot of kind of power users in the Slack channel who are helping other users and talking them through how to get started. And this is the first time that I've experienced this as a, period. But just seeing the community start to really take the reins overall, I think a lot of the core work is still being done by Superconductive, and we plan to always push on it and help the core move forward. But seeing increasingly other people stepping up, contributing, bringing their ideas in, has been really cool. And it's one of the big things that we're pushing on over the summer is streamlining that and making it so that if you help somebody out, it's easy to catch that, not just in a Slack conversation, but in a discourse channel, for example, so that that temporary confusion for one person can turn into permanent learning for the community.
That's great. Well, I definitely have more questions I want to ask you about community stuff surrounding just open source in general. But before we get there, let's talk a little bit more about some of the specific features surrounding GE. I'm also curious, how many tests do you typically see are required in a common install? Like, are we talking about tens of tests or hundreds of tests, or sort of what is, I'm sure the scope can be all over the board, but what's typical in your experience?
It depends, like so many things, it depends. But let me tell you what it depends on. It depends partly on kind of the nature of the data problem you're confronting. So if you go back 5 years, people in the big data community would talk kind of buzzwordy. They talk about volume, variety, velocity. To the extent that you have a variety problem, you probably want more expectations. And the reason is, if you're pulling in data sources from lots of different places and normalizing them or pulling them together into different analytics or things like that, there's just more business logic that needs to be built and more surface area for things to potentially go wrong. So, to the extent that you have more variety, you're probably going to have more tests. One common pattern that we see, and the scaffold workflow that I described earlier supports this, is when people are starting, it's easy to get overwhelmed. Like, you'll often see the master table that has 500 columns that come in from dozens and dozens of different places. And the idea of trying to get all of that under thorough test immediately can be overwhelming. What we find is that there's, I wouldn't call it an 80-20 rule in the sense of diminishing returns, but more in the sense of just like focused value in certain places. Usually if you say, okay, what are the 10 most important columns to get under thorough test? You can actually give yourself a lot of peace of mind. Like a team that goes through and puts, I'm not precise numbers, so don't hold me to this exactly, but 5 to 10 expectations on each of 10 columns in their most important table or two. There's often this tangible like, oh, okay, we can count on, the things that burned us in the last 6 months are not going to burn us again.
Yeah, so you can get incredible leverage immediately just from going after your biggest problem areas, and engineers like immediately feel the benefit from that.
Yeah, that's right. And so I think like the workflow that we want to support is get your infrastructure set up quickly, make it so that it's possible to build the tests, deploy the tests, and then check the results. Get your Slack notification and get your static docs to review them. Make that as quick and seamless as possible. Encourage people to bring the like really critical, burning on fire, painful today systems under light test immediately. And then, just like people often do with legacy code where it's not very well tested in the past, as you go forward, every once in a while, you'll spend a day just adding some tests. Or if you encounter a new bug, okay, you fix the bug and then you test it, so you're sure it'll never happen again. And there's this sense of this nice ratchet effect where you don't have to do a ton of upfront work to be confident that, okay, maybe I'm still going to encounter some bugs, but each time I do, I know it's the last time I'm going to encounter it because it's under test after that.
So are there any anti-patterns that you see emerging around GE, or are there any specific types of projects or use cases that you wish it were a better fit for, but it's not? Talk to me about sort of the flip side for a second.
Yeah, this is actually a really interesting conversation about so you're saying anti-patterns. What I'm hearing is, how opinionated should this library be? Like, people deploy it in all kinds of different places. It's a little bit like the classic pattern of like, what is a bug in software, right? It's not doing what I expect. Does that mean it's not doing what it should? So what I'll say is we're actually doing a push internally right now to think through what are the core promises that Great Expectations really needs to be able to fulfill. And as we do that, I think we're going to get a little bit more opinionated about it. It's too early to telegraph like exactly where that goes, but in order to enable a really good experience around not just profiling one table, but profiling lots of tables, it turns out that like you need to think about, okay, what's a table? How opinionated are we about definitions of tables and data assets and things like that? So it's not so much that I see people doing like, bang your head on a wall dumb things, like not that. It's more, I think we're coming out of a phase where we've sort of deliberately let 1,000 flowers bloom. And from that, we're seeing some patterns that are clearly more productive. And what we want to do is help people see the value in those specific patterns and then figure out how do you bridge from whatever you were doing to that. And maybe that's an immediate quick thing, or maybe it's something that takes more time. But so I think, people should expect to see Great Expectations getting both sort of better documented about what are all the workflows that could be supported, but also opinionated about, hey, if you're using this workflow, consider this alternative, because if you do the alternative, we can also guarantee X, Y, and Z for you.
Yep, got it. I guess maybe slightly adjacent to that is this notion of where you fit in the overall data ecosystem, because that can help you sort of determine on how opinionated you want to be. And of course, you and I have done some fun work together on this recently, but what would you say that, which tools does Great Expectations quote play nicely with?
Mm-hmm. Yeah, so just virtual high five. That was a fun blog post to write. I'm looking forward to seeing where the rest of them go. 25 hot data tools and what they don't do.
Agreed.
So I think the strongest set of complements that we see in this universe are Airflow, and then all of the people who are chasing Airflow. So, with my impression, I'm going to go out on a limb. I think of Airflow as the jQuery of data orchestration. And what I mean by that is it unlocked so many cool experiences. It gave the people this notion of a DAG. And it worked really, really well for a lot of things. However, when you start to build it out and get to scale, it turns out that some of the abstractions don't quite fit. And so jQuery is being superseded by the Reacts of the world. I see the same kind of evolution happening around DAG orchestration. And there are a bunch of players in that space. So Kedro, Prefect, Mara, if you want to kind of go smaller, Dagster, they're still kind of sort of stealthy, but they've taken a very, very ambitious view on where to go with that. And several others, Flight out of the Lyft team. So it's clear that data orchestrators are going to be a thing. And we see them as our natural complements. And in fact, we're working with several of those teams to figure out how do we make integration really seamless and beautiful between those tools. It's a little bit messy because all of the tools are still evolving and growing. And so figuring out exactly how to integrate is going to take some time. But I think that's the natural evolution for this ecosystem.
Got it. So, sort of along those lines, what excites you most about the biggest vision of what Great Expectations could become? What does that look like to you, both as a initial author of a project, now a company founder, which we'll actually get to some questions on as well. But what's your, how does this project change the world?
So I love, I'm not sure if I would have kind of strategically chosen to do open source. I'll actually throw this out. I started off kind of skeptical about open source business models. And over the last year, I feel like I've gotten much more educated. I see how it works. I see how it can fit together. I love that we're building Great Expectations in this purely open, community-driven way, because I think we create, and I'm not dodging a question. This is a real answer. I think we create the most value and get to the biggest possible vision by being expansive and by bringing a lot of people in. The big change that we feel over the last year as kind of the core team is not thinking about it just as a data testing tool, but making this bridge into other forms of collaboration. So compile to docs and data docs is part of that. Profiling is also part of that. It turns out when you start building really good profiling workflows, often more than one person gets involved, and those people have different types of technical skills. And so we don't see it just as testing. We see testing as this very clear, immediate entry point that engineers recognize and see a clear need for. But once you've got that established, as long as you also have the ability to be extensible and to translate to human readable things, it opens up all of these really interesting possibilities for keeping different people on the same page about their data. So we see this natural evolution towards something we think of it as a data contract, where different stakeholders who all care about data may have different needs, maybe even have adversarial needs in some cases, but all come with a different perspective, can all be confident that the data does what they think it does, and they're confident that they know that, and everybody else knows that, because the technology is doing the core validation and then translation out to other layers. So,
is that like an SLA for data? I mean, is that sort of where you think this is heading?
If you want to think about it that way, yeah. And this actually goes to your earlier question about like, where do you deploy it? So that's an SLA that you could deploy at ETL to make sure the data coming in is clean. It's an SLA that you could deploy around a data warehouse to make sure that the business logic of building out your analytics tables and your reporting is clean. It's a thing you can deploy both up and downstream of machine learning models to make sure that the features come in as expected and the models produce the things that they produced last week and you expect them to produce. You can deploy it between teams. You can deploy it between companies. So we're seeing some interesting use cases around data brokers sharing data and people downstream either wanting to guard themselves against unexpected changes or data providers wanting to be able to give sort of self-enforcing data dictionaries along with their stuff. So there are all kinds of places where this can be useful. And again, going back to this notion of open source, actually, let me go personal for a minute. I have spent a lot of my time going back and forth between engineering and communication. And I love engineering a tool that helps with communication, that like helps people stay on the same page. And so that's the bigger vision.
Yeah, that's significant. Getting buy-in from stakeholders, agreeing on common terminology. These are sort of the soft skills of engineering that many of us engineers learn later in our careers because, God, it's sure not the first thing we want to learn. But they're super useful in working in teams. And so I appreciate that you have that collaboration, communication mentality and value that is obviously apparent in the project. How does this relate to the extensibility of your plugin architecture? Like, let's talk about that as sort of a bridge to having the community conversation, which I want to get into as well.
Mm-hmm. So there are several parts of, this is an analogy that I've heard several other open source projects that I admire very much use. I'm thinking of teams like Gatsby or HashiCorp. They talk about trunk and branch, or like core and periphery. I like trunk and branch better because, I don't know, periphery sounds like you're not important, and that's not the case. There are several places where the patterns for how to extend Great Expectations are starting to be pretty clear. So one is connecting to more types of databases. Another one is building out the logic of additional expectations. Another one that we've done less work on, but I think will be big in the future, is kind of post-execution hooks to kick off other jobs and workflows, integrate with other systems. All of those are places where you can imagine, dozens, if not more, of really good integrations. And we're starting to get to a place where those are streamlined. Now, I say starting. This is very much the same place that we were with onboarding back in November at Data Council, where onboarding was starting to get smooth. I'd say contributing to the project, like a big, like, here's a discrete integration, and that can be shepherded through very quickly as a PR. That workflow is still not super easy, but we're working on it. And as more people show up in Slack saying, hey, I want to connect to MariaDB, or I want to build a connection downstream to Mattermost, or I want to extend the data docs to be able to visualize this way. We're steadily getting better and streamlining the process of helping funnel all that creativity into one big shared open product.
And is there a specific area that you want to put the request out to the community here for support in most? Is it this data sources sort of option or connectivity, or are there others?
Honestly, I would say today, if you're interested, reach out. There's a contributors contributing channel in Slack. Just show up there and raise your hand. I'd say the immediate need, like this week, is actually in our documentation. We've just gone through a fairly large refactor of documentation. Part of what we're doing is breaking out these how-to guides that take one bite-sized piece of doing something in Great Expectations. Usually something you can do in less than 10 minutes, often less than 2 minutes. And we're trying to make those really discrete kind of atomic Lego blocks that people can build their systems out of. But there are a lot of them. There are almost 80 docs there that need to be filled out. And it's swamping the core team to develop those. So if there are people who are good technical writers and don't would like to get involved, that would be an awesome way to put your stamp on things right away. I know asking for help for docs is a little bit different than what some engineers are inclined to jump in on first. That's what we need right today. It'd be awesome to get help. In the future, things like data sources and more expectations, those are coming pretty soon too.
Got it. And how can folks connect with you there? Is Twitter the best way, at Abe Gong on Twitter, or are there other ways as well?
So at Abe Gong, to get a hold of me, Great Expectations as a project is expect great data at Twitter. And let's see, if you've got a question that you think other people might have, you can also go to discuss.greatexpectations.io, which is our community discussion forum. It's relatively new, but we're active there. And we're actually starting to try and encourage people to shift questions out of Slack into those discussion forums, because then, again, it becomes a useful long-term thing for the rest of the community to consume.
Great. So on the community front, I'm sure you've learned a lot in the last year or two about managing an open source project. Are there any tips or hacks that you would sort of recommend to others in terms of how to successfully marshal the community around a project? I mean, I can tell from your values and from reading your documentation that communication, again, means a lot to you, and it really shows in the docs that you produce. So I think, to me, that's very meaningful table stakes for any significant open source project. But would you add to that? Are there other things or tricks that you've done that you might share with the community?
I don't think it's so much about tricks as just investing in people. One way to think about it is, I've been told, kind of rule of thumb, when a new engineer joins a team, it's usually about a month before they stop being a drain on the team, right? Like, it takes some time to ramp up and get productive and just be able to really fit in. For open source, if it's going to be like, very few people are going to have the patience to like wait around for a month and figure things out. So you got to figure out how to streamline things. You've got to do the work of really, really streamlining your onboarding. To be totally candid, I don't think we've fully done that yet. I think we've done a lot in the last few months that makes it easier. But one of the things to look for from the project is we're working to a place where we're building out specific kind of step-by-step how-to guides for, if you want to connect to a new data source, here's what you do, like all of the things. Here's how you test it. Here's how you document it. Here's everything. And then within that, also breaking out from a process perspective, what should you as a contributor expect the core team to do? Like, what kind of turnaround times are reasonable? Where is it common to get specific types of feedback? What things will the core team just kind of do for you? And what should you expect to have to do for yourself? And I feel like we're talking about SLAs a lot. It's this kind of SLA around, hey, as a contributor, what can I expect? And our goal is to make that really like fast and convenient and easy. But doing that in and of itself, like it's a sort of product all of its own. And so it's taking real time. It's fun though. Like, I'm seeing people use it. It's one of the most rewarding things that I get to see.
Well, at the risk of boring folks by talking about SLAs longer, and also but actually in acknowledgement of the fact that we've been chatting for 45 minutes already, and I swore that I would never allow any live event approach an hour. Why don't we take some questions from folks, because they've been sounding off on YouTube. And so we have a bunch of great questions lined up that I'm anxious to hear your thoughts on. So first of all, Rick is asking, are there lessons to be learned from existing software testing frameworks, especially those that have gotten the most adoption? I guess that's a who do you look to for inspiration sort of question.
Mm-hmm. That's a really good question. I think we do feel a bit of a departure from software. It's not a departure, it's just existing unit and integration tests are not a perfect analogy for data testing. again, because of this notion that the data is the thing that changes. So monitoring also matters. We take quite a few cues from the observability side of the world, although that also is not a perfect analogy. I don't know them deeply, but I've been really fascinated by a lot of the front-end testing frameworks that allow you to connect user stories very directly to testing of specific components. Again, going to the data world is moving to be more like React and less like jQuery. I think there's some kind of high-level buzzword kind of analogies there. I think there are also some deeper technical analogies that you can draw on. So yeah, it's this interesting place of looking to other examples while also knowing that none of them is a perfect fit for the new world that we're developing here.
Mm-hmm. Understood. So Flavian has another question. Hey, Flavian, how do you handle the trade-off of column level expectations, which is most of what I've heard GE being used for, versus table level expectations? Example, table volume being greater than X.
That's a really good question. We've spent most of our early development time on column level expectations, as you're understanding. One of the things that we're starting to do is set up more infrastructure for cross-table expectations or whole table expectations, multi-column expectations that test relationships between columns. There's some really interesting things you can do with kind of inferring state machines and correlations and things like that. We've held back from that in the open source for two reasons. One, you can build your own. It's not too hard. And two, there's a pretty deep, when you move into that world, it's possible to express the same assertions in many different ways. And we want to be cautious. We want to feel our way forward to make sure that there isn't like tons of redundancy or wasted compute or just confusion in the way that things are documented there. So it's actually a fairly deep, I call it a semantic problem there, like a fairly deep problem saying like, what is the best way to express an idea or an assertion that could be expressed in multiple different ways.
Got it. So a listener from Kabula, another data tool in the ecosystem, is asking, what's the best place for GE in the typical ETL scenario? Does it belong as throughput testing or into a separate pipeline? Would processing data one more time be a negative?
I see. Well, I think I see. It depends, right? So if you're working with really big data, you don't want to touch it more than once. However, if you're working with relative, like, let me frame it this way. When deploying a tool like Great Expectations, you've got two options. One is you can sort of retrofit an existing system and plug Great Expectations in on top of it. If you do that, you'll probably have some duplicate compute, but it's usually faster to deploy and set up. So what we see is for teams that have small to medium-sized data, where it's mostly variety, not volume, that's a problem, that's usually the better fit. If you're in a system where you have really large data being processed through, or if you want to have really tight control over how data gets processed, so you don't want to just validate post hoc, but you want to control the flow of your ETL or control the flow of your actual code. In that case, you've got a tighter integration to do where you're actually deploying Great Expectations checkpoints within your code, within other places. So, I mean, I think that's the trade-off. One deploys faster and gives you somewhat less control and perhaps some less performance. The other one gives you more control, more performance, but at the cost of higher upfront engineering cost.
Got it. So Jennifer is asking, what's the ideal method in this framework for creating new customer expectations? Also, how would this framework allow for an expectation to be embedded in one or many pipelines?
So this is one of those how-to guides that I'm trying to get written this week. If you go there right now, it's going to say it's a stub. So but the old docs do still exist. And if somebody wants to dive in and help write that, I'll get to it before too long. But the short answer is, if you deploy Great Expectations with what we call a data context, so if you run Great Expectations in it and set up all the moving parts, one of the things that you'll get is a built-in plugins directory. And within that plugins directory, you can write custom modules for your own expectations. When you do that, any data sources that import, that use those modules when they import, which you can configure to do by default, will have access to all of the expectations that you've built. And so if you have, I don't know what expectation you're imagining, but expect column value to be prime number, and you want that to show up everywhere, that building into a plugin like that makes it available anywhere that you're validating your data. So it's almost as if it's just a member of the core library. And again, this is part of what we see as the long-term value prop for Great Expectations. You define these semantically meaningful concepts once, and then they can get used all over the place.
So another question from Pawandeep, he's asking, does GE play with other data tools such as DBT, which is a favorite of ours, which also supports data tests and are already being used in some organizations? So that's sort of a how do you play nicely with DBT question.
And when we were talking about data orchestrators, I knew I was forgetting one. DBT is it. DBT is the one I was thinking of. I'm sorry. Yeah, Drew, Tristan, I'm sorry. It was not on purpose.
We'll apologize to Fishtown later.
Yeah. So we see a lot of teams that are deploying Great Expectations alongside DBT. I think DBT provides tests and they do it well. I think the place where we see the most value add for Great Expectations is, let me break it out this way. Some DBT teams are purely within the data warehouse. They live in an almost entirely SQL world. And within that world, DBT is like full stack, covers everything they need. That actually, well, I won't get into details, but that's one use case. The other use case that we see is DBT is one component in a larger data infrastructure system. The data warehouse exists, and DBT does a wonderful job of orchestrating it. And then there are all of these other adjacent components that also need to work, a data lake, machine learning, other things along of that nature. And in that case, if you want consistent testing that flows across all of them and that gives you the semantically meaningful bindings, we can be really helpful. Great Expectations can be a really helpful level up from the core test that DBT provides. There are also some things, if you really invest in profiling or kind of some of the more advanced features around data docs, there's a place where the kind of declarative testing around Great Expectations can also help, even just within a data warehouse. But I'm almost reluctant to say that because DBT does such a good job working in the data warehouse that, like, we believe we can add value there, but I don't want to overpromise, especially when some of those features are still early.
Well, Abe, I have to give you a lot of credit because, I was looking through your docs in preparation for this show, and I realized that not only was the blog post that we co-wrote together that you mentioned your idea, but the whole notion of this concept of what does your tool not do was your idea, and it's embedded in the Great Expectation docs. And so I just wanted to salute you for acknowledging that with this community and really taking a lead in being one of the first ones to sort of come clean and try to avoid the hype cycle and really accurately depict to other engineers what they should expect from your tool and what they shouldn't. And I see that clarity in the way that you communicate about the project and in the way that you think about the data ecosystem. So I'm really grateful to you for that. And I think it's a great model for other tools and other community leaders to show that same kind of transparency and not pretend that they do everything well, because that's just not the way optimizations work. Teams have to optimize and tools have to optimize for values and for use cases and for pleasing some people and not others. So I just wanted to thank you for the clarity that you've brought to the ecosystem surrounding that concept. And I just wanted to put a plug for other tool developers writing documentation to start to adopt a similar notion of being explicit and clear about what their tool doesn't do.
Thank you, I guess. Yes, thank you. I think everybody's better when we recognize that there are lots of like technically deep, interesting problems in the data world. It's not one problem, it's not one workflow. There are a lot of moving parts. There's real complexity. And so I definitely am a person who avoids hype. One things I love about open source is it keeps us very honest, right? Like there's no potential for us to promise things that it doesn't actually do. And yeah, I think that's the healthy way for technology to evolve.
Yeah, agreed. Well, it's almost an hour, so I think it's time for us to wrap up. I just wanted to mention to folks listening that we have another great episode lined up in 2 weeks. We'll be featuring Mark Grover, who's a product manager at Lyft, and he's also the co-creator of Amundsen, one of the data catalogs that we mentioned briefly in our chat today. So you can find a register link in the YouTube description now. If you'd like to get Eventbrite reminders about the event, you can sign up there. It's Mark Grover in 2 weeks from today, same time, same place. And Abe will list other show notes and links to Great Expectation related stuff in the YouTube description as well, so that folks can have access to that. Also, there's a feedback form if folks in the community are kind enough to give us some feedback, constructive feedback, positive, negative. We'd really appreciate that because it would help us make DC Thursdays even better as we go forward. But Abe, big thanks to you for being the first guest. I really appreciate your Johnny on the spot, like agreeing to do it, and all your thoughts and the value that you add to the data community. So thanks. I hope it's been fun for you.
It's been great. I'll just put in a plug. Mark's awesome. You should come back in 2 weeks and talk. Not you, Pete. Everybody listening. Mark's great.
I will be here.
Directions. I know you'll be here.
Well, thanks. Well, thanks, Abe, and thanks to the community for tuning in. We'll see you next time.